Sometimes we have to separate certain color ranges to treat them individually, or we want to cut them out to be replaced by the background. In this example, I created the setup that allows me to change the color of this flower to something completely different. Here's what's possible, and I can very easily make it red, blue, green. In order to make it possible, I needed to separate this original yellow color. And here's another example. This sequence is created using two elements. We have the still image of the mountains and our lady shot against the green screen. That's the original footage that I used. I needed to separate this green color and replace it with the background. This was of course not all, because I had to make some color correction to make this footage match the background. But in this episode I will be mostly concentrating on keying, which may be described as taking the color information of the image and converting it to the alpha channel in the way that we specify. There are several effects available in Blender that do exactly this. They can be found in matte category, and here we have several effects. I have added them all here to be able to analyze them one by one. Difference key analyzes the difference between one image and the other image, and basing on this information it creates the alpha channel. So here into the upper socket I have plugged this image, and I won't be plugging anything to the lower socket, but I will simply sample the color that I want to key out. We have two sliders here, tolerance. When I increase the tolerance, more color ranges will be taken into account. And there is also fall off. And this may be very helpful to achieve smooth transitions between keyed and not keyed parts of the image. This node has two outputs, the image, which contains the RGB information together with the created alpha, and here we have the matte, which is the alpha channel that was created by this node. Distance key. This effect works very similar to this one, but it analyzes the differences between one image and the other in some other way. It simply uses other algorithms. Let's see what is the difference when we use exactly the same values as here. Let me simply copy them and paste them here. And I will also copy the same color. So that's the result that we achieve when we are using the distance key, and that's the difference key with exactly the same settings. This is the matte created by difference key, and that's the matte created by distance key. Exactly the same settings, different results. So depending on the image and the effect that you want to achieve, sometimes you will use this one and sometimes this one. And it's not that easy to determine which one will work best on our particular image. We simply have to try and see. Chroma key creates the alpha channel basing on the chrominance of the color that we choose. We already know what chroma is, and here we have the acceptance, which is similar to tolerance, and the cutoff. But this is completely different from fall off. As you can see, it's impossible to achieve smooth transitions between keyed and not keyed parts of our image. Those values are described in degrees because of the way that chrominance is understood. Here we also have the gain value. Let's decrease it, and we see that we get some semi-transparent pixels. At a first glance, it may seem that this effect is simply worse than the previous two. Jagged edges, no smooth transitions, but that's the one that we will surely use to key out the green screen. And here's the color key. Again, we take the image, specify the color, and we get the key. Here we as well don't have any fall off, but we have the tolerance specified in hue, saturation, and value. So when we increase the hue, more hue ranges will be taken into account. We may increase the tolerance of the saturation or of the value. But as well, we don't get the smooth transitions. In such cases, we sometimes may simply take the matte created by the effect and blur it out. And then instead of using the original matte created by the effect, we will use the blurred version. This is different behavior than the fall off that we have in difference key or distance key. Fall off bases on the color ranges, and blurring the matte itself will blur all of the edges no matter what color we have here or here. Then we have the channel key and luminance key. Let's start with the luminance. It's not that difficult to guess that it bases on the luminance value of the image. That's the matte, and we can play with those sliders to specify the ranges that we want to cut off. This is in fact exactly the same as passing the luminance of the image through the converter color ramp. The input of color ramp is gray, which means that it accepts the single value. It won't accept the image as the input. When it gets the image, it converts it to the black and white version of this. When we take a look at the matte created by the luminance key, when the values are set high to 1 and low to 0, we see that we get exactly the same image as this one. Okay, not exactly the same, because as you remember, luminance can be calculated in various manners. But let's, instead of plugging the image directly to color ramp, let's pass it through converter separate YUVA. And now this ramp bases on the luminance from YUV model. Let's compare it to the matte created by this node, and it looks like this. That's the color ramp, and as you can see, we have exactly the same images. But this node limits us only to use the luminance from this model. And we can create our own matte using just the color ramp, and here we can plug whatever value we want. Luminance from this model, or converter RGB to black and white. Let's see the difference. In fact, we can plug in anything we want here. We may separate the image into the RGBA channels. Now let's plug the image here. And we can, for example, plug the red channel here, and we can create the matte basing just on the red channel of our image. And when we take a look at it, we may compare this behavior to using the channel key. Here's the channel key, and we see that we have the high value, low value, and it's exactly the same as moving those sliders. And here those buttons specify which channel of which color model is taken into account. So here I have plugged the red channel into the color ramp. So when I use the red channel here, take a look at it, I can move those sliders to the points close to those ones, like this and this, let's say, and I don't get the same result because of the algorithm that is used here. Here it says max. So it's like analyzing the difference between all of the RGB channels and the red channel and taking the maximum of the two. We can use different algorithm like single, and now we are keying the red channel limited by the green channel or limited by the blue channel, and those sliders specify the tolerance. And we can use the RGB model, HSV model, YUV, YCBCR, and at the first glance it's not that easy to determine which options should we use, but we already know all those models, we know what channels are responsible for, so after a little bit of playing with this node, we will surely appreciate the power of it. Okay, let's break down the examples that I showed you at the beginning of this episode. I'm sure that this example is more exciting than the flower, but before we begin to run, we need to learn how to walk. So I want to change the yellow color of this flower to something else, and I will now try to create the best possible matte. So let's try one of the effects that we already know. I will try a distance key. Sample the color and see what happens. Increase the tolerance, and as you can see, I cannot go too far because I begin to have problems here. Let's take a look at the matte. So let's lower this. Now let's introduce some fall off. And we also begin to have problems here. So maybe lower the tolerance. Okay, let's leave those settings, collapse this node, and try the difference key. Sample the color. And taking a look at the alpha channel, let's increase the tolerance. but not too much. Increase the fall off. And when we move them too much, we also see that we begin to have some problems here. Okay, if you ever believed that there is an effect that creates the perfect matte automatically, you are very optimistic. In most cases, we have to combine several mattes together. So let's simply treat those as some initial adjustments, initial mattes. Maybe a simple color key. Let's sample this yellow color and try to play with hue, saturation, value. Let's take a look at the matte. We get jagged edges, but in this case maybe we can simply blur it out. So I will add a filter blur, use just a fast Gaussian, plug the matte here, take a look at it, and blur it out some. We would also want to cut those parts. This is also yellow. So maybe we should pass this image through another color key, take a look at it, and sample this color as well. Of course, in this case, we should lower those tolerances, especially the value. Let's take a look at the alpha channel. And maybe we will get the good matte when we pass this matte through the blur node. And it's in fact not that bad. I think that I can use it as the factor of the effects that I want to apply. So let's maybe select those nodes and collapse them. Delete those two. And now I will add the color mix, take the original image, plug it to the upper socket, take a look at the result. Completely white image because we are mixing the original image with the white color with a factor of 1. But see what happens when we plug this as the factor. Well, definitely not what we wanted. We have to invert this. There are several ways of inverting the images. We can use color invert. Simply plug it here and we are done. This is one way. The other way would be to use converter, color ramp, plug it here, and click the F to flip those values. So that's another way. Or we can use the math. Inverting is subtracting the value from 1. So we can use converter math and simply take this and subtract it from 1. So here I will type in 1, change the blending mode to subtract, I mean the operation to subtract, and plug it here. Or another way, we could as well use color RGB curves, plug it here, and swap those points. Okay, but in this case, let's simply use the invert option. Let's collapse this. And here we can change this color to something that we like. But when we use the mix blending mode, we are simply mixing this image with the color that we specify here, so it covers the area specified by this one. This is definitely not what we want. How about we want to lower the influence of this effect? Well, normally we would simply change the factor from 1 to something else, but we have plugged something to the factor. So we don't have the direct access to this. But this value can be modified, like we can multiply it by something. Let's use the converter math, plug it here, let's take a look at the result, but instead of adding 0.5, let's simply multiply it by, when we multiply it by 1, we don't change anything, but if we make this value lower, we are decreasing the influence. Let's set it to 1. But this is definitely not the effect that we want, so how about changing the blending mode to color? This will take only the hue and saturation of this color into account. The value didn't change. We may as well use the trick to preserve the luminance. I would like to preserve the luminance basing on the algorithm that is used in converting RGB to black and white. So I will add converter RGB to black and white and take the black and white version of the result. And I will also duplicate it and take the original black and white version. And to preserve the luminance, I will subtract this from this. Converter math, subtract, take the original luminance, subtract the resulting luminance. And to be sure that we are doing everything correctly, let's combine this into the image. I will combine RGBA and simply do something like this. Now it's an image. And we can take the mix node, change the blending mode to add. And here is our difference in luminance. So I will take the original and add this difference. And now I can play with this color. Okay, so that's walking. Let's start running. By running, I mean creating this composition. But I will take care about it in the next episode. That's the setup that created this. We have several nodes responsible for different aspects of our image. Here we have some groups, and I will break this all down to explain how I achieved the result that I showed you.